She should. That's what vacation's for. She should be having a good time. But yep, two new special kind of parallelograms. One's a rhombus, the other one's a square. So again, they are still parallelograms, so all those properties hold true, plus a few that make them unique for themselves, okay? And they should be getting easier and easier. So rectangles are kind of whatever. Today we do rhombi. You'll be like, oh, this is a little easier than a square. It's just like everything's the same because it's all equal. But we'll see what that looks like in just a second here. Okay, so let's kind of dive into a rhombus. Like I said, it has all the properties of a parallelogram plus these three specific ones to the rhombus. What do you guys think? All four sides are equal or congruent? Yep. So now take one of your colors out of the three you chose and let's highlight all four of our sides, okay? Just so we remember that's what makes it a rhombus. So on the outside, highlight all of your four sides because they are the same length. So it's kind of like a square, but it's just like slanted over because all four sides are the same size. Okay, diagonals are,
Congruent.
we want to say congruent, but no.
Equal.
Nope, not equal.
Exterior. Interior. Perpendicular.
Perpendicular. Do you guys see that little right angle right there? So those four right angles that are created from when your diagonals intersect are 90. They're always going to be 90 in the middle. And then the last one's a little goofy. Diagonals blank opposite pairs of angles. Yeah, it is bisect. So now take another one of your colors, and this is where it gets a little goofier. So like these two angles right here and here are the same, and then the ones across from them are the same. So those two right there, a diagonal from each other, they're all four the same measure. So if they were all 40, it'd be like 40, 40, 40, 40. They're all the same. And then grab a different color, and then these four angles would all be the same measure. Okay? So opposite angles are equal, and then since they're being cut in half, they all end up being the same measure. Okay? You'll see what that looks like better once we put some numbers in there, but you still have it in your diagram marked up. Okay. So again, we're just going to practice with these properties. If we start here, let's just label what we know. So we're told that JK is 12 and JN is 7. So that's just our given information. So what do you guys suppose JM would be? Yeah, because all your sides are the same length. So they're all going to be 12. Maybe you want to write that, I guess. We could do that. 12s all around. Okay, what about J to L? Yeah, 14. 7 plus 7 gives us 14. What about MN?
7.
We wish it was 7, but it's not a square. Yeah, that's a right angle there, right, you guys? So this is 7, that's X, here's 12. Okay, what side is our hypotenuse?
12.
Right, so that's the guy that's all by himself. So 12 squared equals X squared plus 7 squared. It should be a decimal, yep. I'm going to say it's 95. Square root of 95. 9.7. Anyone disagree with 9.7? Is that what you said? Okay. So MN is 9.7. What would MK be?
19.4.
19.4. Beautiful. You guys want to get a head start on the next one? Same kind of idea, just different numbers. You'll have to do Pythagorean theorem once, I believe. You guys get a head start and I'll catch up to you. Is it 529? What's 23 squared? Is it okay? $11 something. 11.4. So GH. Are we okay with that, folks? Anyone still working? Okay, good work. Now the angles I think are kind of fun because it's just a big puzzle and there's only going to be 3 different angle measures that we have on the whole thing. Let's start with the easy part. What's always going to be in the middle of a rhombus? 90. Yeah, so why don't you guys label these on your picture just so it's a good reference for you later on. They're always 90 in the middle. And then I have 38 given to us right here. There's 38 in 3 more places. Where are they?
3, 4, 5.
Yeah, 3, 4, and 5. Because this angle's being cut in half, and these guys are equal. Perfect. And how do we find our missing ones? Oh, you guys are good. Yeah, subtract from 180. Tell me what you get. That's what I was thinking. So that was pretty easy, right? You should never get more than 3 different angle measures. 90's in the middle, and then whatever your corners are. Then we have a little bit of algebra before we talk about squares, okay? Some of these are pretty straightforward, like this one. GH, we're given something about, and JH, what do we know about those 2 segments? They're equal to each other because all of our sides are the same length. Gonna get a decimal, that's okay. 2.75?
Yep.
Did you even try it yet? Was I going
No,
too long?
75.
It should be 2.75, I believe.
Yep.
Okay. Okay, the next one we're given something about our angles. Maybe we should trace out where they're at. Angle JFK. JFK is this little guy right here. And angle KFG. That little guy right there. What do you guys know about those 2 angles? They are equal. Yeah. Because our diagonals bisect our opposite angles. Are we okay with 4? Okay, perfect. Now our last special parallelogram we have is a square. think if you had like a rectangle and a rhombus and you mashed them together, smushed them together, you would end up with this cute little package of a square. So it has all the properties of a parallelogram, all the properties of a rhombus, and all the properties of a rectangle. So kind of basically everything is just equal, right? Only two different kinds of angles. What's in the middle? 90s, and what are in the corners? Always. They're never going to change. Otherwise, it's not a square. So let's just see what we can do with these guys. Okay, we are told that AD is 11. And we can find everything else out from there. Okay, what would BC be? 11. Now they want us to find AC. What do you guys think?
It would be something.
Yeah. If you were to draw out, do you guys see how we have a big, right triangle? So what would AB be up here? 11, right?
It's 15.6.
I think that sounds right. But yeah, you can work it out for Pythagorean theorem. We should double check Landon to make sure he's right, but I'm thinking he's pretty close. What is the square root of 242?
15.6. Wow. Just like that.
15.6?
Yeah.
Okay, thank you. What about BD? Yeah, the diagonals are the same, 15.6. And then EC? Do you guys think?
Alright, take a number.
Yeah, divide by 2. All right, good work. Now our angle measures. Angle DAB. Yeah, the big guy in the corner is 90. Angle AEB in the middle here, 90.
90.
What about angle CBD?
45.
I agree.
Yeah, I agree.
And angle BAC?
45.
You guys are incredible.
Yeah.
Very good. Very good. Okay, let's stop.